All right, let's talk about how we're going to represent organic molecules. I'm going to draw the same molecule in a number of different ways. Um, First off, we talk about its molecular formula, which you learned about last year, C6H14. Um, it's telling me how many carbons there are, it's telling me how many hydrogens there are, but other than that, I'm not getting a lot of information as to how this molecule looks, because there are a number of different ways to put 6 carbons and 14 hydrogens together. Expanded molecular formulas, they start to get a little bit more, give us more of an idea of what this molecule looks like. So here I start breaking it apart. I got a CH3 attached to a CH2. That is just terrible how this thing keeps making my bad handwriting even worse. CH2 attached to a C, attached to an H, attached to a CH3, attached to a CH2, attached to a CH3. Each time. All right. So best is if you don't understand what I've drawn there, I'm going to actually draw a full-on picture of it now. This is what this molecule actually looks like. This is a carbon with an H, 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 and I'm not going to correct all these H's. CH3, attached to a C with 2 H's. Another one, yes. Attached to a C with an H, and a C with an H and a CH3. Attached to a CH2. This could be the worst drawing I've ever done because of the sensitivity of this tablet I'm using. But I've got CH3 attached to a CH2, attached to a C and an H, and another CH3, and a CH2, and a CH3. That's what I've drawn right here. Easier than that is instead to actually write CH3 attached to a CH2, kind of combining the best of both worlds, a CH, and then up here to another CH3, to a CH2, to a CH3. And this is a nice way to put these diagrams, or to draw these diagrams. I often will draw them like this, or like the last one we used. Line diagrams, textbooks use them, web pages use them if you're online. What they do is every time at the end of every line or a bend, I have a carbon atom with enough hydrogens to make it happy. So I have a carbon attached to another carbon, attached to another carbon, the carbon up here. So what I have here, and I'll change colors, this means I have a carbon here, 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 and here. Every bend and every end. Bend, end, end. Okay? And that's what I have here. Carbon attached to a carbon, attached to a carbon, attached to another carbon. That's little 3 up here. But I rarely use these in class. What I often will do in class is go C, 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 and then I will put just little lines here, and at the end of every line it is understood for there to be a hydrogen, because I just can't spend the time to fill in all those H's. It drives me crazy. So I will often draw diagrams in class either like this or like this. Those are my two favorites, but we need to be able to recognize all of them because we'll see all of them as we look around. And that's how we represent organic molecules.